All right, so on my last handout, while we're breaking into this one, and then we'll come back to that one, is I didn't include a good enough section or any section really on some of the most fundamental uses of sine, cosine, tangent, cosecant, secant, cotangent. And that would be to find missing sides, find missing angles of right triangles. So let's look at the way some of this works. As a reminder off of some of the first videos so far, this is our memory mnemonic. Meaning sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So the first thing we're going to do is look at this degree angle and realize to this degree, this is the adjacent side and this is the hypotenuse. So adjacent and hypotenuse is cosine. So the problem we're going to set up is cosine of 20 equals adjacent over hypotenuse. Now, I'm going to turn to my calculator. The first thing I'm going to do is hit this. This is going to be an off to the side, but hit the mode button. And then when you scroll down, you're going to see about the fourth line down, you're going to see a choice between radians and degrees. And we're going to be back and forth through these two choices in the upcoming sections. But right now, we really want to make sure that degrees is selected. Otherwise, our calculator is not going to do what we want to do. So my calculator's in degrees. I'm going to actually type in cosine of 20 into my calculator, hit enter. I'm going to get something like 0.9397. Then I'm going to multiply x to both sides so that it's off the bottom of this fraction. Then I'm going to do 12 divided by 0.9397 and get something like 12.77. So we can leverage trig ratios to find missing sides. So on the next one, we look at 40. That makes this the opposite over the hypotenuse. So to relate these, we're going to write sine of 40 equals x over 15. We're going to go sine of 40 is 0.6428 x over 15 times both sides by 15 and get something like 9.64 equals x. Moving onward. Looking at this angle from this angle, this is the opposite side. This is the hypotenuse. So sine of 62 equals 20 over x. Sine of 62.8829. 20 over x. Multiply both sides by x to get it off the bottom. And then 20 divided by that decimal. Okay, now 59. Also looking at opposite of 59, and this is the hypotenuse. So another sine of 59 equals x over 42. Sine of 59 and we get something like 36.001 equals x. Moving down from this 54, this is the adjacent side to 54, and this is the hypotenuse. So now we're at cosine of 54 equals x over 76. We go cosine of 54. It's 0.5878. Goes x over 76. Multiply both sides by 76 and get something like 44.67 equals x. And finally, from here, from the 20, we got opposite. And this 50, 150 is an adjacent. So now we're actually our first appearance of tan, x over 150. So if we go tan of 20, get something like 0.36397 was x over 150. Multiply both sides by 150. 54.596 or so, and get x. All right, so now the next couple problems are purely just to see if you can draw the triangle and then do the same thing. A ladder leans up against a wall. So here's our ladder. Here's our wall. 71 degrees, it says, with the ground. 15-foot ladder. So this is 15-foot ladder. Find the trig ratio you'd use to find how high up the wall, so x. So from this 71, this is opposite to hypotenuse. So sine of 71 equals x over 15. If we go sine of 71, times both sides by 15, we can answer that with a 4.18 or thereabouts. Airplane taking off from the ground. So here's the ground. The hypotenuse of our triangle is our airplane path. It's making a 12-degree angle with the ground. It has, so we're going to end up probably finding the actual height, right? Oh, the distance. Okay, distance is flown. So it has covered 1,700 horizontal distance. So that's telling me that the 700 comes down here. But you want to find a distance it has flown. That means upward and outward. So really, you're right here, right? And what that's telling me, once I got that set up, that this is the adjacent side. This is the hypotenuse. So we're going cosine of 12 is adjacent over hypotenuse. Multiply both sides by x. Divide off the decimal. So when it's covered 1,700 feet horizontally, it's covered roughly 1,737 feet, 0.98 total, because it's also flying upwards. All right. Now that's always finding a missing side. Now let's go one step further where we can find a missing angle. A lot of overlap, a little something new. All right, so from this angle, this is the side opposite, and this is the hypotenuse because it's opposite the 90-degree angle. So that's sine of x equals 4 over 7. Now, if you look at your calculator and you hit the second button in the upper left-hand corner, and then you hit the sine button, because it says sine of, above it, it says sine to the -1, which is our inverse, how we undo sine. So we're going to take sine to the -1 of 4/7 to the negative first power to reciprocate the sine under, allowing us to cancel the sine, so on and so forth. So sine of 4/7. And we find out that our x measure must be 34.85 degrees or so. So in here somewhere, 34.85 degrees. All right, so from this angle, this is the adjacent. This is still the hypotenuse. So now we're with cosine of x, 38 over 50. We're going to do the second. Now we're going to hit second cosine, because that will give us the cosine to the -1 of 38 over 50. So and we'll get something like 40.54. And then from here, opposite over hypotenuse. So again, this tells us to use sine. So sine of x equals opposite over hypotenuse. We're going to use the inverse of sine to undo sine. So we'll do that. Second sine button, 16 divided by 37. And we'll get something like 25.62. Couple word problems to finish it out. Building a skateboard ramp. Ramp is 7 feet long and 3 feet high. Let's just call it like this. 7 feet long. Find the measure it makes with the ground. So it looks to me like this is the adjacent, this is the opposite. So that screams TOA, which is tan. So tan of x equals 3 over 7. Inverse tan to undo it. So second tan of 3/7. Looks like the angle it makes with the ground is 23.1986 degrees. A building that's 14.5 meters tall casts a shadow. So let's draw some sun so that we have a shadow. Hi, sun. Casts a shadow. Here's it casting a shadow to the ground. 11.4 along the level ground. So it's telling me to do 11.4 here. At what angle do the rays of the sun hit the ground? So that's telling me what is this. So that's, again, also telling us this is the adjacent. This is the opposite side of that angle x. So we're thinking TOA. Tan of x equals opposite over adjacent. So if we inverse the tan, we end up getting an angle of 51.83 or so. One last one. 5.2 meter ladder. Bottom of the ladder is 1.9 meters away from the wall. What angle does it make with the ground? So we got adjacent over hypotenuse. This is going to scream cosine, TOA. So cosine of x equals adjacent over hypotenuse, which means I'm going to get this thing done. And end up being able to answer my question with something like 68.57 degrees. All right. Well, that's a quick little insert into lesson 9.1.